Hi everyone, and welcome back to this series of electrical A1 circuit exam. This is an interesting question. It asks you to find the voltage V delta, okay? And basically, when you look to the circuit, it looks spooky. It's very, if you want to deal with the raw circuit, that would be time consuming, regardless whatever technique you want to use. If you want to use nodal or mesh or KCL KVL, which is the worst among all in terms of efficiency, it will take you forever to solve this question, okay? So these type of questions is the DC analysis. Basically, the key point that you need to do as much as circuit reduction as you can, and then you can pick any technique. So you try to reduce the circuit, okay, until it reaches to certain level, and then you can apply nodal, mesh, or KCL, KVL. Personally, I like nodal analysis. I find it very efficient, okay, but it's up to you. But here, what the key point, never ever deal with circuit at its raw condition. So let's see the question. Now, this is the question. So the first thing I would do when we have something like this, try to number the nodes, okay? So this is node number 1. This is node number 2, node number 3, node, so this is all 3, this is all 2, all of this is 1, okay? This is 4, this is 5, and this is 6. So you have 6 nodes, okay? Now, clearly that the 12 ohm and the 4 ohm, they are in parallel because they are sharing node 1. So this is, again, this is 1, and this is 1, this is 2, and this is 2. So they are in parallel. And the 10 and the 2.5, they are also in parallel. So basically here, 12 and 4, so it's 12 times 4 over 12 plus 4. This is 3 ohm. And here, 10 times 2.5 over 10 plus 2.5, this is equal to 2 ohms. Okay, so now I will take the circuit to the first basically reduction here. Now these two, and I will keep the noding. Do not remove the node numbering. This is very, very important to be able to see the things in the circuits, how to basically move from one circuit to another. Sometimes, like in this example, we need to do maybe 1 or 2 reduction, not just 1. So this is the 3 ohms, and this is the 2 ohms. Okay, this is the 10 ohms here, and this is the plus minus V delta. Okay, this is the dependent source minus plus V delta over 2. And here it is basically your 20 ohm. Okay, and this is 2 ohm, and this is 5 ohm. Now let's number the nodes. So this is 1. Okay, this is 6. This is 2. This is 3, 4, and 5. Okay, so this is the first reduction that we have done. Now we need to do source transformation. So we have a voltage source, which is 60 volt in series with the 2 ohm. Then basically I can substitute this with a current source in parallel with a resistor, okay, with R. And this is just V divided by R. So I will do the second reduction here. So basically I will have the current source, which is 60 divided by 2, so it's 30 amps, in parallel with the 2 ohms. So this is the 2 ohms. So this is node number 1, and this would be node number 5. This is, so because the 2 in series between 1 and 5, so the parallel will be 1 to 5. Now the 5 ohm resistance is between also 1 and 5. So this resistance is also in parallel with the 2 ohm. So we have here 5 ohms. So this is all 1 and this is all 5. And then we have the 3 ohm, then the 2 ohm, the 10 ohm, and now you can see here this 20 and this 2, they are in series. If there is a current going this way, the current that goes here is the same current as the one that goes the 20 ohm. So I can add these two together, and I can put them before the source or after the source. I will put them before the source. So this is 22 ohm. And then here I will have the supply. And this is V delta divided by 2. Doing this is extremely important. This is, I would say, more than 50% of solving the problem. Because now if the problem is like that, it becomes easy to deal with. Okay, so this is clearly nodal. So let me write down the node. So this is node number 2. This is node number, basically number 3. And all of this node number 5. Node 4 has been dissolved because I moved the 20 to and emerge it with the 2 ohms. So this will be my ground. Now, what is the voltage at node 2? It's clearly it's the V delta. V delta is the voltage difference across the 10 ohms or between node 2 to the ground. So this is your V delta. This is one variable. What is the voltage here? I will call it V1. That's something that I don't know. What is the voltage here? It is basically minus V delta divided by 2. It's a voltage supply. So now we have 3 nodes. We identify 2 unknowns only, V1 and V delta. That is the whole number of unknowns. So all I need is 2 KCL from nodal. That's it. As simple as that. So at this problem, so we basically apply KCL at V1. And again, here I'd like to mention that I'm trying to solve the questions quickly. I don't have, of course, the answer. So sometimes there are some calculations errors. I'd like here to thank everyone sent me the comments. It's very helpful to everyone who reading the questions. So I can do the modifications or in the course, in the video description, so that people that know that, okay, this calculation is wrong, okay? But the most important thing is the idea, how to approach the problem. So V1, we have 1, 2, 3, 4 branches. So we have the current that goes here, V1 divided by 2, plus this current, V1 divided by 5, plus this current, V1 minus V delta divided by 3. And the current is entering the node is equal to 30. Now, multiply everything by 30. And adding the terms, you will have 31 V1 minus 10 V delta equal to 900. Hopefully the numbers are correct. So this is the first equation. One equation to unknowns. I need another equation. So basically apply KCL at V delta. So we have 1, 2, 3 branches. So we have to have 3 elements in the equation. Now, the current direction in the previous step has nothing to do with the current direction with this step. So let me basically here change the color not to do any confusion. So basically the current direction is this way, and that way. So to the right, it is basically V delta minus V1 divided by 3 plus down V delta divided by 10 plus V delta minus V delta divided by 2 divided by 22 equal to 0. 1, 2, 3 elements. Okay. Now this will becomes V delta minus V1 over 3 plus V delta divided by 10 plus 3 V delta divided by 44 equal to 0. Multiply everything times 660, and this will give me basically one equation after modification is equal to 331 V delta is equal to 220 V1. Okay, and from this you can say that V1 is equal to 331 V delta divided by 220. So this is equation number 2. Substitute 2 in 1 and then solve. then you will find that your V delta is equal to 24.6 volt. And V1, when you substitute in this equation, will be equal to 37 volt. Now, the whole idea of nodal, once I know the node voltages, so I know this node voltage, I know this node voltage, I know this node voltage, and I know this is equal to 0. If the question, for example, asks you what is basically the current in this branch, what is I1, for example, it's V1 divided by 2. Very simple. If it asks you what is the current here, it is V1 minus V delta divided by 3. If I ask you what is the total power consumption, basically it is I squared times R. You find all the currents. It's basically I squared in the current in that branch times R. If it asks you what is the total power that is basically supplied, then you know the voltages, you know the current, you can find what is the voltage, the power supplied by this source and by this source. Everything in the question is, after that becomes very easy to calculate.